Hello, everyone. Thank you very much for joining. So let's hang on. My slides are not changing for whatever reason. Let me try again. Must be a keynote change of some kind. Let's see. Okay. So yeah, I've been a RabbitMQ contributor for a while, and technically I'm a senior staff engineer at VMware, and this beaver emoji suggests how much actual engineering I do these days. I use this handle on GitHub and in most places. Yeah. So I think I understand what's going on. So whenever someone joins the waiting room, Zoom brings up a window which blocks everything for me. So it's a model window. Yep. So not 100% sure how to best solve this. But... Oh, okay. Is it changing now?
No, we cannot see your screen actually at this time.
How about now?
We can see it.
Right. So yeah, as I said, I'm a longtime RabbitMQ contributor. You can find me most places on the web using this handle. And today we will cover schema storage in RabbitMQ. So this talk is actually a follow-up one to a talk delivered 2 years ago, I think, on Mnevis, another approach at schema storage. So let's quickly recap what is problematic about the schema data store that we have in RabbitMQ 3.8, let's say. So RabbitMQ historically has been using a built-in distributed data store that ships with Erlang. It's called Mnesia. It was created for certain specific hardware appliances, and it is consistency-oriented, transactional, and very opinionated about how it recovers from failures and certain operational topics. It basically assumes that your set of nodes is relatively fixed, let's put it that way, and it doesn't really fit very well into modern data services. Although there are people who push it to remarkably, like to incredible limits, but it has been a pain point for RabbitMQ developers and users because partition handling modes, for example, only exist to work around certain niche opinions. When Mnesia gets into a network split, the only way it can recover is one side has to reset and has to rejoin the rest, which can be very, very inconvenient as far as, well, both to users and developers. So this is the problem we're trying to avoid, more or less. So what do I mean by schema, by the way? So everything that's not messages, basically, your queues, exchanges, bindings, your runtime parameters, users, permissions, and so on. Replacing Mnesia has been a long-term goal for our team. And so next I'm going to cover where we started a few years ago and why we are now reconsidering that design. So if you have been to the previous RabbitMQ summit, you might remember a talk on Mnevis, which is an earlier attempt at solving this problem and replacing Mnesia by using it as a node local transactional store, because honestly, those parts, like it works well enough for us, and I would say for many people. So in this design, if you use Mnesia as a node local store, then transactions are propagated and acknowledged between nodes using a Raft cluster. By the way, folks, may I quickly, yeah, collapse some Zoom UI elements. So yeah, transactions are propagated using Raft. We already have a Raft library. We know how to use it. We know what operational aspects it has. And this is one maybe group of distributed algorithms that we certainly have a lot of experience with. One problem with Mnevis is that it cannot coexist with distributed Mnesia, so there is no realistic upgrade path. If you, let's say, ship Mnevis in hypothetically 4.0 or something like that, a 4.0 node will not be able to coexist with, let's say, a 3.9 node. So blue-green deployment is your only upgrade option. Also, for that reason, because you have to remove all your previous uses of Mnesia, at least you have to change most of them, it becomes a massive slam dunk, all or nothing kind of change. And I'm sure you have seen some of those over the course of your careers. It's really scary, it's painful to merge, it's too easy to put on the back burner, like we cannot realistically stop much development and just work towards this. But if you don't do that, then you know all other changes to the code base become a moving target that you, like one or two engineers who are working on integrating something like Mnevis, they cannot possibly keep up. So yeah, replacing one of the key subsystems in a data service is apparently not particularly easy. It's a bit like refueling your airplane mid-flight, or even repairing it, to be honest. It's borderline impossible for certain products. So is there a better way to do this? So something that wouldn't make merging a very long and painful process seem particularly off-putting, and maybe even provide an upgrade path besides blue-green deployments. So yeah, ideally it should be something incremental, right? And if you think about it, we have kind of already did this in a different area of RabbitMQ a few years ago. So we introduced quorum queues and the idea of queue types alongside classic mirrored queues, right? And classic mirrored queues were for the most part not affected. You didn't have to stop any work on them, or you didn't have to change your applications to quorum queues overnight. So Khepri is a project which is an evolutionary approach to changing the schema database inside of RabbitMQ. So it is inspired by TCT or Zookeeper or any number of similar stores. It's open source, even though it's very much a work in progress. It is primarily Erlang and meant to be embeddable. It's a Raft-based store, so things like replication, recovery strategy, and all the safety and availability characteristics of Raft, they all apply to Khepri. One thing about Khepri is that because it's a clean room design, it can use any local key value store for its storage needs as needed. Doesn't have to use Raft log for everything. So for example, at VMware Research, there is a project called SplinterDB. It's a key value store designed for non-volatile memory storage. And according to their paper, it is 10 or more times more efficient than RocksDB. I mean, if something is 10 times more efficient than RocksDB, it must be incredibly efficient. So this is one area, two research projects that at some point we will try using together. I don't know if SplinterDB is open source at this point, but I thought I should mention it because at some point it will be publicly available one way or another, as far as I understand. So Khepri, being a new distributed subsystem, it can be adopted incrementally. So for example, we already have a prototype that uses it for virtual hosts, users, and permissions. Because those objects are very simple, they fit into the key value model beautifully, we can easily start with just that. Then we can do things such as connection tracking or runtime parameters and /policies, because again, they are basically, it's like it's either a key value data model or a nested key value data model, meaning your values are also maps, right? And we can do the same thing for plugins, Shovel and QTT, maybe even more plugins with slightly more complicated data models, such as consistent hashing and delayed message exchanges. Although the delayed message exchange will probably need a more substantial redesign. This is one area where using Khepri together with SplinterDB would be particularly interesting. And then at the very last step, your queues exchanges and bindings specifically, that's the hardest part to migrate, because queues and exchanges, they use multiple tables, in fact, and bindings, some binding types use, some exchange types, they store their bindings as, say, trees with an IE. So they are, nested maps of prefixes, if you will. And that does not necessarily fit the key value model, at least it's non-trivial to fit everything into that. So that has to come at the very last step. So yeah, why is it great that it can be adopted incrementally? Well, I think the benefits are more or less obvious, but let's go over them. So it can be developed and mature over time with little risk. It can be hidden behind the feature flag, and even though we don't have the concept of reversible feature flags, in this case, it should be straightforward to go back between Khepri and Mnesia for at least something. So if you disable it, your users will be stored in say, Mnesia again, and if you enable it, they will be stored in Khepri. There are many features that are good candidates. So we use Raft for several features inside of RabbitMQ, but also a lot of features like shovels. They internally use, they could use Raft for leader election, because you want shovels to run, one shovel to run on one cluster node at a time. And so that's a leader election problem, first and foremost, if you ask me. And yeah, we use Raft for metadata in MQTT plugin, and the list goes on. I'm not trying to suggest that everything should use Raft, but Raft is a very natural choice for a lot of things, and often those features are entirely independent and orthogonal. So many plugins like Shovel, but federations, on another example, are effectively small distributed systems within a RabbitMQ cluster. So they need a data store of some kind, and again, we can, with little risk, migrate them independently. And with Mnevis, that would not be possible, because Mnesia cannot be used in both distributed and node local fashion. Some features, like I said, can be ported in a few days. So if something can be done in a few days, procrastination is unlikely to become a problem. This work can be parallelized between not just different engineers on our team, but also our team and various community members. But Khepri, being a key value store, which is consistency oriented based on Raft, it lacks multi-key transactions. And that is probably the biggest problem we have with it. You can add some features that are already found in similar data stores, such as etcd or Zookeeper. So you can have watches, so when a certain piece of data in your tree changes, you can register a notification, things like that. Another feature that we have in Khepri already is conditional operations. So you can use them for upserts or conditional reads, meaning if you want to declare a queue, you can, for example, check if a virtual host exists and then insert or wait on the watch, things like that. This is needed when you import definitions, where you import a whole bunch of data all at once. and it can happen concurrently. And well, obviously you cannot declare a queue in the virtual host that hasn't been imported yet. So yeah, this sounds like a lot of stuff, and let's maybe focus on some specific aspects. So as I said, Khepri uses Ra, our Raft implementation internally. I don't think we have mentioned it in any of the talks, but Ra 2.0 in RabbitMQ 3.9 supports multiple subsystems in a cluster. So what is a Ra system? So imagine a feature such as quorum queues that uses Ra and it optimizes for, say, throughput. It needs a certain set of settings and defaults, even though there is no such thing as a good default. Unfortunately, some defaults are slightly more optimal for most users. You have to optimize for something inevitably. And say another feature such as MQTT client ID tracking, which actually has high churn and uses really, really small records, like literally less than 100 bytes, I think. It needs a completely different set of settings. You can potentially limit the amount of memory it uses heavily, so it only needs so much to keep so much data in RAM. And you may optimize for, use smaller segments, which means data will be reclaimed on disk like faster. So yeah, because of the high churn, right? That data doesn't leave potentially for that long. So Khepri in this, if you, now that you know what Rust systems are, Khepri then becomes a new Raft system or a new feature with its own set of settings and defaults. And you can back it up separately. You can, well, we will get to it towards the end, but some things that are completely unimaginable with RabbitMQ today might potentially become possible. So one thing that is important to mention, like any route-based system, Khepri requires the majority of nodes to be up. This would be the case with Mnevis as well. So if you lose a majority of your nodes, then it won't be available for writes or consensus or distributed reads. You would still be able to read your local data, but it may or may not be good enough. And for RabbitMQ as a whole, it likely won't be good enough. So as I said, Khepri is very much a work in progress. For example, deletes are a feature that was introduced like yesterday, and we don't really properly compact data. It uses the same approach as quorum queues, which is sufficient in some cases and not great with others. Data is not compacted as quickly as possible. But for Schema, that's probably reasonable because, I mean, most clusters may have a lot of messages, but they don't have that much data. As mentioned earlier, it was easy to adopt for virtual host users and permissions without like any optimization and any detail to efficiency. It offers like double-digit throughput improvements over Mnesia. And this is all stock raw defaults, no splinter DB, literally nothing. The smallest possible Ra-based state machine that we could come up with. So when will it ship is another nice question. Like I said, you're not forced to use it. It can be adopted incrementally. It can begin shipping in 3.10 or even 3.9, although I doubt anyone would allow me to ship it in 3.9 in a patch release. But yeah, it can ship in 3.10 behind the feature flag. It can actually, I think Tanzu RabbitMQ, our commercial edition, will probably adopt it earlier for various plugins because it makes, once it matures to a certain point, it wouldn't make that much sense to continue using Mnesia for certain data, let's say. And yeah, I think future releases of distributed plugins, such as the, well, 2 exchange types, right, mentioned at the top, they can adopt it earlier. I'm not sure about Federation because it's a plugin that ships with RabbitMQ. So there is only, like, we have to follow a reasonable versioning scheme, even though we try to not produce a lot of miners because we are legally obligated to support it for a certain period of time, and no one wants to support like 6 versions in parallel. It's not going to be realistic. So yeah, let's step aside for a moment and talk about Kubernetes. You have seen that Kubernetes is a very big deal, not just in our industry, but VMware as a company and the Tanzu part of VMware specifically. Virtually all of our products either based on Kubernetes or extend Kubernetes, or Kubernetes experience is a like priority number 1, more or less. So what can Khepri mean here? Now, Khepri can act as a gateway drug because it is similar to etcd in terms of API, even though it's not 100% and it's not our goal to reproduce etcd, the entire feature set they have. There are many similarities in both strong kind of aspects and pros and cons, because both are similar in their interface and both are Raft-based systems. So once Khepri is integrated fully, which I don't know when that's going to happen, but it would make it possible to potentially abstract Khepri entirely and use an external schema data store that looks similarly to etcd for storage. I don't know if that should necessarily be a good idea, because we have seen in our industry that people try to move away from depending on things like Zookeeper because it affects the end user experience. It makes upgrades more problematic, and I don't know, some people just don't trust external dependencies. And so it would be moving like zigging when other people are zagging, but well, introducing an option at least. But it would, I think, benefit Kubernetes users in the sense that if you back up your Kubernetes cluster using whatever state-of-the-art Kubernetes backup projects are available at that point in the future, then all of your RabbitMQ clusters are automatically backed up. Now, some may argue that with all the operator work that we have, all of that will be solved long before Khepri is fully integrated. But I can definitely see how for RabbitMQ, like in the context of a specific platform, that would potentially be a desired feature. This is not, just to make it clear, this is not something that we intend to work on at the moment, but some members of our team believe that this would be a very interesting area to explore. So yeah, thank you, and let's open up for questions.
Thank you, Michael, for the talk. Let me try to find, and Ilya, if you can ask your question yourself.
Yep. So about backups. So what we back up, like should we do snapshotting on like what level, and like do we backup leader or like any node and then care about like that it somewhat passed behind the leader. Yeah, so how backups work generally in RAW-based systems, probably it's close to this.
Yeah, so we're talking about schema specifically here. So what will be backed up is the state of the schema as we have it in Khepri. Yeah, in etcd, those would be called snapshots. Or is it console? I keep forgetting. I'm sorry about that. But yeah, you can take a snapshot of basically your Raft-based state machine, in which case it will represent the state of your schema in a RabbitMQ cluster. As for backing up messages, it's a very different problem because your data set can be absolutely massive. And well, we are working on alternatives for that. In fact, in Tanzu RabbitMQ, you already can replicate your schema incrementally, very efficiently to a remote data center. So we are working on a solution for messages as well. Well, even though on the surface they may seem similar, they're completely different design with completely different priorities. So yeah, storing messages in Khepri is not a goal. I don't think it's going to be a good idea for many reasons, but one of them is right now we replicate messages between streams, for example, by completely avoiding Erlang distribution. It remains to be seen if we will do the same for Khepri, because honestly, the data volumes there are small. It doesn't necessarily make much sense. And in that case, you know, moving your entire message set over that, it's not going to work very well. Well, yeah, but there are risks to doing it that way.
I mean, when we say take snapshot of state machine, we are talking about files still, right? So the files.
Oh, we're talking about the actual state machine, which is spread across multiple files, and some of those files have tombstones and so on. So it's not like, you know, cp-r your data directory. First of all, you're backing up a cluster system, so it will be the state of the machine as observed by the leader. Well, specifically when it comes to etc storing state in etcd, to be honest, it will be done the way etcd does it, which I'm not, honestly, I haven't researched that part yet in a lot of detail, but semantically you're backing up the state of the leader because yeah, that's the source of truth in a RAF-based system. But it's not really like cp-r. It can be done in all kinds of ways.
Okay. Thank you for the answer. Thank you for the question as well. Adam, Casey, if you want to raise your answer.
Hey, yeah, thanks for the talk. It's really interesting to get some details on that. My question is, would it help if RabbitMQ had a well-defined network protocol for internode communication outside of the Erlang distribution port?
Would it help what specifically?
I guess part of the reason for this is to make upgrade process easier. If there was a network protocol in the way, well, not in the way, but if there was a defined network protocol, is that going to achieve some of the same things, or can it help the upgrade process?
Yeah, I'm trying to understand, like, how is it? It's a good question, but I'm trying to understand how is it related to Khepri. But let's say the Erlang distribution does have a well-defined API. In fact, in terms of RabbitMQ, we re-implemented with compression. So it has been well-defined for over a decade. Would it make sense to entirely avoid using Erlang distribution? I don't think so, because it gives you transparent communication with remote processes in a way that is like reasonable. At least in the most recent Erlang releases, there are many things that have been refined. If you replace that, then you're, you know, completely responsible for doing all of that. And in RabbitMQ, say raw replicas, they do identify themselves in part as process IDs, and the same is true for multiple things, from federation to replicate mirrored classic queues, or just routes into queues actually. And it would be like a massive amount of effort with unclear benefits to replace Erlang distribution entirely. Erlang distribution is not bad. You just need to be mindful of, you know, not overloading it. So some data streams should use separate connections. Others, like, it's incredibly convenient that we have this in Erlang. It really stands out. So yeah, I wish I had it something like that in Go and other programming languages. So I would keep it for most things, at least things that don't transfer a lot of data.
Thank you.
Thank you.
Adolfo, if you want to raise your question. Okay, if you are not here, at least we cannot hear you. The question was, where can we learn more about Khepri?
Yeah, so the best way of learning about it is learn a little bit about RA, because you wouldn't be able to read the code if you don't know anything about RA state machines and how RA, what parts of Raft RA handles for you and what are your business logic, your actual system specific behavior. Once you have a basic understanding, like you go through a RA tutorial, you can just open up Khepri integration suites. They are relatively focused. The API, I mean, it's a work in progress. It may seem a little silly to some people. If you have never used etcd or console, it may seem like a weird approach to key value stores. But then all of Khepri as of yesterday, I think, is less than 2,000 lines of code and like 1,000 lines of tests. So, and it already can do certain query types. I think basic deletes are done. And one thing that I did not mention is that it can do things like right now, if you have to delete, let's say a queue is deleted and it has 500 bindings, you have to, and they are topic exchange bindings, you have to delete hundreds of rows, right, in Mnesia. So you have to potentially acquire a fair number of logs. In Khepri, it would probably be just like deleting a directory. It can be a one-shot operation, which is efficient, not particularly expensive, things like that. So it can already do a fair amount. Obviously, I cannot compare it to Mnesia because they have different data stores, different features. But you can, at this point, you can dive in easily. It's a small project. Now, I can tell you that the person who primarily works on it probably wouldn't necessarily appreciate people joining to contribute immediately. But soon enough, it will be realistic. So.
Thank you. Gabor, if you want to raise your own.
Yes. Although my question just been answered. So is there any possibility to keep a non-consistent version of RabbitMQ after this change? Something like what AutoHeal does today. As much as I want to get rid of Mnesia, but it's a nice addition as a feature in some use cases.
So yeah, like if you are trying to build an inconsistent system based on Raft, it's an uphill battle. You can do local reads. I think for some things, maybe local reads would be like a reasonable approach. Although to be honest, when you tell a developer that your authentication read can come back inconsistent, they just panic and run away. But yeah, like local reads which are not consistent because they don't go through the leader is the best option you have. Can Khepri be a practical data store inside RabbitMQ by only using local reads? I don't think so, but maybe for some specific features, like reading bindings. I think that could be reasonable. Like you read bindings locally as efficiently as possible, but if concurrently some other client updates your bindings at exactly the same moment, you probably don't need serializable level of consistency, right? Many people would be willing to sacrifice it. By then, your binding operation become very efficient. Something like that, yeah, can be done.
But just to clarify this, does that mean that RabbitMQ will be able to work with 2 nodes with Khepri?
Sorry, work what way? I didn't get that.
Work with 2 nodes, for example.
No, not really, because there is no such thing as a majority with 2 nodes, and Raft assumes that there is a majority. So no, but some features would potentially be able to become like to remain being available when your node is in a minority. But again, I'm not sure if you would actually want this. But yeah, maybe like serving metrics. If we ever use Khepri for something like that, I think you can do local reads. In fact, with Prometheus, we only serve local metrics, right? But I think you would be able to cover like a small digit, low single digit kind of percent with local reads.
Thank you. We'll see how it will work out.
We still have a few minutes, so please, if you have any questions, do raise them. I have one question in the meantime. So as far as I understand, the raw library uses disk, always uses disk to store the log. So is there any chance that for some use cases, some memory-based logging or memory-based storage will be implemented, because not everything needs to be persisted to disk? Let's say if the cluster goes down fully, I don't know, some values are not needed to be kept, but you would want them to be consistent while the cluster is up, for example.
Yeah, in my opinion, everything should be persisted to disk. You can keep another copy in memory, which is what RA does, and you control how much it keeps for efficiency. But yeah, I haven't been around RabbitMQ operating, helping people operate clusters and so on. I am very, very deeply convinced that everything should be kept on disk, and people who ask for RAM nodes, which by the way, we have officially deprecated with 3.9, and 100% kind of in-memory based storage based on Raft specifically, like it's a terrible idea. Raft assumes that every operation results in an AppSync. We obviously practical Raft implementation optimize it, because for some operating systems, you will cause kernel panics if you try to do 2000 of syncs a second in parallel. We have been there. So no, everything should be stored on disk. If you don't need something stored on disk, just don't store it in a Raft-based system. It's not like there is a shortage, right? RabbitMQ specifically uses ETS for a lot of things, and it's good enough.
Okay. Thank you. We have a question from Cosmo. I don't know if you...
Cosmo, would you like to unmute and ask your question?
I think you are unmuted, but we still cannot hear you.
Oh, my bad. My microphone was muted. Yeah. Hi, everyone. Hi, Michael. So Khepri has a better footprint than RA as it is now, or it should be more developed so it can be consistent?
I'm sorry, it has better what than RA?
Footprint.
Well, what kind of footprint? Memory, disk, or what? Or CPU?
In every much of everything, I mean about the results in general. Because I think in most of part, we're going to be using the logic memory so we can do some prefab at the disk. So I think most part of that is going to be the major tree, the CPU, memory, and disk bound.
So Khepri is a RA-based system, so it cannot possibly be more efficient than RA in general. It can be maybe with some specific cases. Like I said, we can use a local key value store for some operations, but there ultimately will be a Raft log with certain state. So I think it will be about the same. Both of them will be disk heavy by definition. Like I said, if we ever adopt SplinterDB or RocksDB or something like that, well, SplinterDB is optimized for NVMEs, so which is like the latest generation of SSDs, if you will. The faster disks you have, the better any RA-based system will perform. In terms of memory, again, it's configurable how much data is stored in memory per RA system. So there will be a setting specific to Khepri. As for CPU, Khepri does a lot more than RA. RA doesn't really do that much. It delegates to a state machine, but obviously Khepri will do some additional work there. But I somewhat doubt that the CPU will be your bottleneck, given the use case.
Gotcha. Thank you.